All right, example number 2 on direct variation. So given that Q varies directly as R, so they have not written the word varies, they have just given you a statement which you're supposed to interpret what it means. And Q is a half when R is 10, find an equation relating Q and R. Now, if Q varies directly as R, then this implies introducing a constant K, then Q equals to KR. Substituting the values given for Q as a half and R as 10, then we find that K is 20. So writing 20 where we had introduced K, then we find that Q equals 20R. This is the equation relating. So to find the equation relating two variables or any variables, you have to look for the value of K, the numerical value of K, so that now you substitute and write the equation relating the two. All right. Inverse variation. So we've done direct, we look at inverse. Now, consider a situation of two boys who can eat a loaf of bread in 5 minutes. Now, if we increase the boys from 2 to 4, obviously they will now take less time. So if 2 boys can eat a loaf of bread in 5 minutes, 4 boys would eat, if they are eating at the same rate, a similar loaf in 2.5 minutes. So the number of boys increases by 2, the time decreases by a half. As the number of boys increase at a factor of 2, the time decreases by a half, which is the inverse of 2. That means now, this is an example of an inverse variation. If a variable x increases as another variable increases in the same ratio, or the inverse ratio. Let me repeat. If a variable x increases as another variable y decreases in the inverse ratio, then x is said to be inversely proportional to y, written like this. X varies inversely, reciprocal, inversely. If that be the case, then we introduced a constant k, the constant of proportionality, as x equals k over y. So inverse variation written like this, introducing k, we come up with the general relationship. The vice versa is true. What we mean again is that if this is increasing and decreasing, it can also be decreasing and increasing. All right. So we look at an example. A quantity m varies inversely as a quantity m. That means a quantity m varies inversely means 1 over n. That's what it means to be inverse. So if m is 2, now if I introduce k, then this implies that I can write m equals k over n by introducing a constant of proportionality. Now if m is 2, substituting, so allow me to write the word substitute. 2 equals to k when n is 4. So what is the value of k? That means k is multiplied by 4, multiplied by 4, so you get 8. So putting k there, then we have m equals 8 over n. That is the constant of proportionality is 8. The equation relating m and n is this one. So what is the value of m when n is 8? So m, let me put it here, m equals 8, the value of n is 8, and therefore is equals to 1. So this is part C, this is part A, and this is part B. So the value, the constant of proportionality is 8, the equation relating m and n is this, and the value of m is that 1. All right, so that is an example of inverse variation. We will look at more examples in the next clip. Thank you. So this is what we've been able to do, that process. Now, what you need to note here is that as n increased from 4 to 8, m decreased from 2 to 1. Now, look at the increase, 4 times 2, decrease 2 times a half. All right, then we will continue with that with the next examples in the next clip.